Hello students, your maths teacher Mukesh sir is here with you, class 9. As you know that the triangle chapter has been completed from your maths book, and so the syllabus of term 1 also has been completed. That is, half yearly syllabus has been completed. Okay, so from today onwards we will start the revision, and this is your revision video from the chapter number 1, that is number system. Okay, and it is your revision video, and I am going to explain some concept so that you can revise it and you can learn it. And after this video I will send you one worksheet, and you have to solve that worksheet. All the questions you must solve in your fair copy. Okay, so see this revision work. This is a number line. Here it is given number line. We can increase right side as well as left side from the origin. This is origin O point. Okay, and at the origin everything is 0. So when we will move right side, the numbers will be positive. This side numbers will be positive, and when we will move left side, then the numbers will be negative. Okay, and all these negative and positive numbers together called integers. All these numbers called integers. Okay, so here are some points. Point wise I am going to explain. Natural numbers are starting from 1 2 3 4 5 6 up to infinite. All the positive integers starting from 1, these numbers are natural number. Natural numbers can never be 2 upon 3, 1 upon 7. Okay, natural number is a complete number. So these numbers start from 1. These numbers are known as natural numbers. Whole numbers start from 0. 0, 1, 2, 3, 4. All these numbers are called whole numbers. Now student, one difference you can see the natural numbers are starting from the number 1, and you can see in the whole number all the numbers, natural numbers are in whole number, starting from 0, but from 1 to 3 up to infinite, you can see these natural numbers are included in whole number. So we can say that all the natural numbers are whole number, but we cannot say that all the whole numbers are natural number. That we can't say that all the whole numbers are natural number, because 0 is not a natural number. Okay, 0 is not a natural number. That's why all the whole numbers are not natural number, but all the natural numbers are whole numbers. Is that clear? Next, integers. You can see integers. What are the integers? Integers, all the negative and positive numbers. Negative and positive numbers represented on the number line are called integers. So these are the integers, and integers denoted by the letter Z, whole numbers denoted by the letter W, and natural numbers denoted by the letter N. Okay, so these are the definitions of natural number, whole number, integers. And also you know the prime numbers. These definitions you know: prime numbers, odd numbers, even prime number also. There is one number that is even and prime, that is 2. 2 is an even number as well as it is a prime number also. So 2 is a natural number which is even number as well as the prime number also. Okay, so now next definition is rational number. What are the rational numbers? All the numbers which we can write in the form of P upon Q. All the numbers which we can write in the form of P upon Q are called rational numbers. Example: 1 upon 2, 3 upon 4, 5 upon 6. All these numbers are rational numbers. Okay, where P and Q are integers, and in which Q denominator can never be 0. Okay, it will never be equals to 0 in a rational number. When the rational number in the form of P upon Q, we can say P is a numerator and Q denominator, and Q will never be 0, will never be equals to 0. This is the property of rational number. Next, that is irrational number. Okay, irrational number. A number is called irrational number if it cannot be written in the form of P upon Q. If a number we cannot write in the form of P upon Q, that is called irrational number. Next, decimal expression of rational number is either terminating or non-terminating recurring, means repeating. Decimal expressions are two types. Maybe the numbers will be terminating or repeating decimal numbers. Okay, so two types of numbers, terminating and non-terminating, recurring means repeating. Thus we say that a number whose decimal expansion is either terminating or non-terminating recurring is a rational number. For example, student, I am going to tell you the example. You can say 3.14. It is a terminating number because after the decimal 2 digit and it is completed. Okay, and the next one is repeating numbers. We can say 1 2 1 2 1 2 1 2 and so on. This 1 2 number is repeating. Okay, so this is non-terminating, and also it is non-terminating because remainder is continue remainder is there, and the numbers are repeating. That is called non-terminating recurring number. Okay, is that clear? Next, the decimal expansion of an irrational number is non-terminating, non-recurring. Irrational number. Now we are talking about the irrational number that is in non-terminating and non-recurring, means non-repeating. For example, 0.10, 1001, 0001, so on. So here you can see there is not a proper digit which is repeating. After decimal only 1, then 01, then 001, then 0001. So not a proper value is repeating, and still there is a remainder. Okay, so this number is called irrational number. This is non-terminating, non-recurring number. Is that clear? And the next one is all the rational numbers and irrational numbers taken together. We can write down these numbers together. Make a collection of real number. Okay. Next, a real number is either rational or irrational. Real number, both can be real number, rational or irrational also, because we can represent these numbers on the number line. That's why these numbers are real number. Okay, root 2. Suppose root 2 is an irrational number. What we can represent this on the number line, as you have done in the previous exercises. Okay, so root 2 is a real number because we can represent on the number line. Next one, if R is rational and S is irrational, two numbers are there, rational and irrational, and we are adding or subtracting. The answer will always be irrational number. It will remain always irrational number. Okay, suppose 2, we are adding 2 is a rational number, or 2 upon 3 rational number plus root 2. So this is rational number and this is irrational number. But when we will add, the answer will be irrational number. Same as if we will subtract, then also the answer will be an irrational number. So this property you must to know it. Okay, next point. Every irrational number can be represented on a number line using Pythagoras theorem. I told you that all the numbers, rational or irrational, we can represent on the number line. That's why these numbers are called real number. Okay. Next point I'm going to explain. Rationalization. How we can rationalize and what is the method to rationalize and what we have to rationalize. Rationalization means to remove square root from the denominator. This is the meaning of the rationalization of a fractional number. Whenever a denominator is coming in square root form or cube root form, you must to remove that square root, okay, of the denominator by using the property, and this is called rationalization. Suppose the question is given 1 upon root 2. So you have to rationalize by multiplying root 2 upon root 2. Then the answer will be root 2 upon 2. This is the final answer. In the answer, whenever your answer is coming as a denominator in the square root form, you must to rationalize to remove the square root from the denominator. Then your answer is correct. Okay. So that's why we have to rationalize. Here the question is given 3 plus root 5 upon root 2. To remove, we will multiply both numerator and denominator by root 2. By multiplying root 2, we can remove the square root from the denominator. Okay. And now here it is given as first number is given 1 upon a plus minus root 2b. Its rationalization factor, see, it is given a plus minus root b. Okay, when this type of number we will rationalize, then what will be multiplying? We will multiply in numerator and denominator by which number? That I am going to explain. We have to multiply a minus plus root b. Here you can see this is plus minus and here minus plus, means if plus is there then multiply with the minus sign. If minus sign is there then multiply with the plus sign. We can see one example I am going to explain you. You can see the example. Suppose 2 upon 2 plus root 3 is given. 2 plus root 2 is given. We have to rationalize. Then we will multiply by 2 minus root 2. Opposite of this number, that is also known as conjugate. Okay. So we will multiply by 2 minus root 2 upon 2 minus root 2. Then the answer will be upside, that will be 2 minus root 2 upon downwards a minus b, a plus b. A square minus b square, that will be 2 square minus root 2 square. Okay. So final answer, what final answer will be there? 2 minus root 2 upon the square of 2, that is 4. The square of root 2, that will be 2. So 4 minus 2, that will be 2. Answer will be 2 minus root 2 upon 2. Okay. So this is the answer. So whenever we are multiplying or rationalizing the denominator, you must know the symbol of this type of question. Okay. If plus is there, multiply with the minus. If minus is there, multiply with the plus. Okay. So these were the rules from the chapter number system. Okay. From the first chapter. This is your revision points. You please watch this video and solve some questions based on this. And you will get the PDF and you have to solve that worksheet. Okay. God bless you. All the best and thank you.